3.4, combining transformations of functions. So now what we're going to do is we're going to start putting all that stuff together that we just learned. So you have to remember a couple things, right? You always do your stretches and compressions first, right? Then do your slides second. So it's probably the easiest way. So we looked at this in the last lesson. So here is it, A, F, B, X minus C plus D. That's just a general way it looks, right? So A, vertical stretch compression by a factor of A. B is the horizontal stretch. Now remember, it's 1 over B because it's backwards. So for instance, if it was a 2, right, it's half as wide, right? Translate C, shifts left to right, and then translate D, right, up and down, positive or negative. Okay, so here it is. We got a graph. So describe how y equals 3f x minus 2 plus 1 changes the original graph. So there's the original graph. So we don't have any points for this, so you could list the points. So what I kind of do is, one of the easiest ways is, for instance, whatever graph you had, you lift your x values, you'd list your y values, and you get them from the graph. You could put them in whatever it happens to be. Let's look at what happens to the x's and y's. So let's look at here. We got a 3, we got a -2, we got a 1. Which one of these affects the x? Well, this one right here, the x minus 2, that is going to shift the whole thing, all the x values 2 to the right. So what we do is, whatever x value we had here, we go x plus 2. That's what affects the x. What about the y values? What affects it? Well, this 3 makes it 3 times as tall, and this 1 shifts it up. Which one do we do first? Well, we know we do the stretch first, so it's 3y, and then we shift the whole thing up 1. So for instance, if you had a bunch of points in x, you could plug that x. So if you had a 0, you'd plug it in, the new value would be a 2. If you had a 1 over here, the new value would be a 3. Then if you had some values of y that goes with it, you plug them into this equation and list the points. Then what you could do, you have your original graph, you have your new points, sketch out what the new graph looks like. That's a really easy way if you're struggling with what this is going to look like based on the original graph. Okay, so let's look at this. 2 more examples. This should make it clear. So example number 2. We have a graph, y equals f of x. This one tells you, hey, it's stretched 3 times as wide, shifted 2 spaces to the left, and vertically stretched by a factor of 5. Write the equation of the new one. So let's look over here. This should help us create the equation. So we have our x and y values. So what happens to x first? It's 3 times as wide. Okay? So that's our 3x, and then it's shifted to the left, so minus 2. What happens to the y? It's 5 times y. Now, what we got to do is we got to translate this 3x minus 2 into what the equation looks like. Well, if it's 3 times as wide, the 1/3, remember, it's 1 over b, so it's 1 over the 3. And this is x plus 2, because what number do we plug in there to make that 0? -2, so that's our shift. And where do we get this 5 from? Well, the 5 goes out the front. So then we can create our new equation based on that. So y equals 5f, brackets 1/3, x plus 2. Now, if we also had a vertical shift, that would be out the back here, either positive or negative. So it's not that bad. It's the x that's kind of backwards that you have to worry about. Okay, example 3. If the point x comma y lies on this graph, then what point must be on the graph of this one? Okay, so first factor out the 2. Now, if you look at this, tricky, we're going to throw some weird things at you. X has to be by itself, so you have to factor out the 2. So when we factor out the 2, right, 2x divided by 2 is just x, 2 divided by 2 is 1. So that changes the way it looks here. Now, if you look at this equation here, 4 things are happening. 4 things are happening. So what happens to the x? Remember, we do the stretch and compression first before we do the slide. So this is a half times x, remember, because the 2 out there is a half times x. It's going to shift it -1 to the left, so it's 1/2 x minus 1 is our x value. Y, yeah, 3 times y, and then -1. So whatever value you pick, you can put any numbers in here. Then you would just plug them into this to get the new x and this to get the new y. So this is a really simple way, if you're really struggling with what to do with the graphs, to find the new points. And this will work for when we get into sine and cosine, which is later on in the course. We'll do the same thing. Okay, so that was lesson 3.4.